Hello and welcome to Learn ADS in 5 minutes. This is tutorial 34 on understanding bounding area layer for FEM simulation in ADS. Before we get started, gentle request, if you haven't subscribed to my channel, go ahead and subscribe. Once you subscribe the channel, click on the bell icon to enable all the notification. After watching the video, if you like the video, click the like button and share it with your friends and colleagues who may be interested in watching similar tutorial. Now let's get started with our tutorial. Till now, whatever simulation we have been doing using FEM, we are using a concept of lateral extension to define our substrate stack up or the substrate dimension. Remember when we go to EM setting under options, physical model, we have been setting this lateral extension. I have been talking about what's the right number to set here. Now, depending upon what number you set here, if I go to 3D EM preview, ADS will define the substrate size using this dimension here from the edge of the conductors which you have. For example, here if you notice 3D EM preview, you have 30 on either side of this patch antenna except the port size because I have used a TML port which is like a waveguide port, so it truncates the definition in this direction. Now here you also have a simulation box, and this simulation box basically is the amount of air around your structure, and the height of this box gets controlled by vertical extension in the EM setup window. So with the combination of lateral and vertical extension, you basically control the size of the problem what your FEM simulation has to solve. Now, many a times this is good enough because designers just need to draw the metal they are interested in solving, and with these two settings, it automatically sets the stack up and the size of the problem. So most of times you're good. But there are times where you might not have luxury of simulating, this much of substrate, and you want to limit the size of substrate, and you want to decouple the simulation box from the substrate size so that you can see the impact of limited substrate size affecting your circuit performance. The way to do that is using bounding area layer concept in ADS. Let's see how we can do that. So once we open the stack up definition, you can see there is no a layer which is bounding the size of this dielectric, and there is no layer assigned to do that. Now from the list available here, I can pick any layer which is not used in my actual stack up definition. So here I just use a bound layer, and now you can see the bound layer will truncate or dominate the size of this dielectric. Now once this mapping is done on your stack up, I can come back to layout, and now using the bound layer here, I can go ahead and draw anything here, and that will be your substrate size as well as shape. For example, if I just draw a rectangle on the bound layer, make sure you select the bound layer before you start drawing. And once I have the bound layer, and if I look at the 3D EM preview, you will notice this will be your substrate size, and the lateral extension will be computed from this edge here, as you can notice here. So this is your dielectric size, and now you have surrounding, air around that substrate. So this allows you to see the impact of finite amount of substrate available around your structure. Now, in case you are not always dealing with this, kind of rectangle or a square kind of substrate, but mostly that's the case, but not always. What if I have a specific, shape of the dielectric to be modeled? I can use this polygon, and now instead of drawing it as a rectangle, I could draw it like a polygon, and I can draw the shape according to the size of the PCB which I have available. Now, once we do this, notice what happens now. This patch and edge is very close to this dielectric, and this might impact my antenna performance. Now, using this concept, when I perform FEM simulation, and let's have a look what I mean here by looking at the 3D EM preview. Now, FEM will respect whatever you have drawn here, and what you see in 3D EM preview is what FEM simulator will end up simulating. Notice here, now your dielectric has a specific shape as you wanted. And when you run FEM simulation, any distortion caused due to this finite amount of dielectric available will be captured here. Well, that's your 5 minutes learning about bounding area layer concept for FEM simulation. Hope you liked the video. Go ahead and subscribe to my channel and like the video and put your comments in the comment box below this video. Thanks for your time.